are in the pulp. And then within the dentin is the cell process within the tubule. And usually with the low magnification or with the preparation of the slide, the odontoblastic process isn't there. So you just see the dentinal tubules with all the mineralizing dentin around it. And then remember, the last layer that's laid down is going to be the organic matrix, which is pre-dentin, made up of type 1 collagen and ground substance. And then when these odontoblasts make a new layer of pre-dentin, this previous one is going to mineralize, like right along here. That's the wave front of mineralization. So what I want to be able to do is just, this is like you're turning this diagram in this direction so that then we can look at the first picture on the lab sheet. Okay, so I gotta that. So we're looking at this picture here. This is a decalcified section. And way out here, this would be where the DEJ is in the crown or the DCJ in the root, just not way. So this is the pulp side, and A is showing a young pulp tissue that's highly cellular. So then you identified it on the diagram before, Elia. What's letter B showing right here? What are those cells that are all lined up in the pulp? You said it today.
Are you talking about the odontoblast, like the layer?
Yeah. So that's the B is the odontoblast, all lined up in the periphery of the pulp. Remember that odontogenic region of the pulp. So those are the odontoblasts. I'll just write that. And so then what's letter C? That last layer is called what? Not dentin, but.
Is it pre-dentin?
Okay, good. That's the pre-dentin. And then where the D is, that's just showing you the dentin. And then right here, there's that wave front of mineralization along here. A new layer of pre-dentin will be laid down, and this one will then mineralize. What you can see at a very low magnification, it just looks like fine black threads or hair. Those are the dentinal tubules at a very low magnification. There's not a letter there for them because you can't, but that would be letter F. You know, those little tubules. So when we look at it at a higher magnification, it's the same. I can see here's the pulp tissue. Here B, these are the odontoblasts at a higher magnification. C is showing you the pre-dentin, and D for the dentin again. And then F is where I can see the dentinal tubules at a little bit better magnification going through the tissue. And then when that's magnified a little bit more, you can see like the white channels on the far right. Those white channels are the tubules. And what I'm having you see with the letter E is the little purple thread. That's the process in there. So it really takes a high magnification to be in a decalcified section to be able to see the cell process in the tubule. Okay, so this is where this white channel is the tubule, and then where the purple thread is, that's the odontoblastic process that you can see at a higher magnification. So A is pulp, B odontoblast, C predentin, D dentin, E odontoblastic process, F is the tubule. Okay, so we can see tubules on decalcified sections. So let's look now at the ground section at the under B and C. And what you're seeing, the ground section, again, it's on the left-hand picture, this shows us really nicely the S curvature of those dentinal tubules. If we follow, got that nice S curvature right along there. That's the pathway. The odontoblast that made the dentin in this area started up here and it moved pulpally and apically. This is actually where the pulp chamber is. It's a ground section, so there's no pulp in it. And if the odontoblast would be down there. So it just shows it moved pulpally and apically. And
What did you say the X was?
that, well, that's just where the odontoblasts start. The X is actually, that's actually the enamel. I didn't say that's the enamel, and this is the DEJ, which is scalloped at higher magnification that we can see in letter C. You can see that scalloped outline of the DEJ at a higher magnification. So this would be enamel right here. But can everybody see that this is representing the tubules? There's, you know, millions of tubules in dentin. That's the main structural element. And remember, the only reason why there are tubules is because as the odontoblast is forming dentin, it has an odontoblastic process that just keeps lengthening and lengthening as more and more dentin is produced. So all the tubules have this S curvature. You know, caries follows the tubules pulpally and apically. On the right-hand picture, the higher magnification does show you, like where you see the white outline is the tubule, and inside the tubule is the odontoblastic process. And it shows how they branch at the DEJ. You can see the branching and the branching of the odontoblastic process, and then therefore the tubule also branches. Now, when the odontoblastic process crosses over the DEJ, so just picture like a little finger crossing on the enamel side, then we call those little projections the enamel spindle. It's just a odontoblastic process that just crosses the DEJ a little bit and extends over onto the enamel side. So they're actually structures in enamel. Okay, picture B shows us a couple other things. One thing I want to show first of all is, that's not a good color. Let me get a darker color. From here to here, from the DEJ all the way to this spot, that's showing us the primary dentin, all the dentin that form during tooth development. And then at low magnification, this is actually some secondary dentin that's forming. So this is all primary, and then this is just some secondary dentin that was forming. So you can see the abrupt change in the tubules. You go from having this S, and then they go like this. They just change horizontally there. So this is the primary, and then this would be the secondary, and it's actually showing you regular secondary because that's a neat arrangement. The other thing the picture shows is mantle versus circumpulpal dentin. Out here, the first few layers of dentin formed during tooth development. That's the mantle dentin. And then all of the dentin, whether it's primary or secondary, all of the dentin excluding mantle dentin is circumpulpal dentin. Okay, and then let's just I'm gonna just have you look at the next pictures, and then these pictures right here, and then we're gonna stop. So D and E represent crown sections, but again, we can see pretty clearly the mantle dentin and the circumpulpal. So here's the mantle, the first few increments of the dentin, and then the rest of the dentin, whether it's primary or secondary, is circumpulpal. So there's mantle, there's circumpulpal. You know, this would be the enamel, and then here's the DEJ. Okay, so going back to this picture again, I had gone over that there are incremental lines in dentin. So whenever I use that eraser, it's like I have to start over. Okay, so we have normal increments of dentin that are like resting lines in bone and cementum. And that normal resting lines. So every day they make 4 microns of dentin, and then they stop and rest. That creates an appositional or incremental line that's just like a resting line in bone and cementum. But in dentin, those normal appositional lines are called the incremental lines or imbrication lines of von Ebner, named after a Dr. von Ebner. And then I mentioned to you that sometimes the odontoblast can be disrupted so that, look at that layer of dentin's not as wide, nor is this one. Or I could just add another one in there so that these layers of dentin are really close together, so that on a slide it's going to look like a thickened dark band. So let's look at that on the slide. So if we look right here, this accentuated, the dentinal tubules are going in this direction, the S curvatures. And then at right angles to it, here's a area where we see this dark band at low magnification with the white arrows designating it. That's a contour line of Owen. That's accentuated. Now at this magnification in D, I can't see all the little tiny normal incremental lines, but if I go over to this picture, I can see them, and they're all those little tiny, the arrows pointing to the direction of the tubules. So all these little lines in here represent the von Ebner lines. You can see all of them, I'm just not drawing across them all the way. Okay, so those are the imbrication lines of von Ebner. So we best see them on ground sections. Then finally, over on this picture, this is the CDJ or the DCJ. Okay, here's this is cementum. And then this just shows you that even on a decalcified section, mantle dentin shows up differently. So here's the letter C is just showing you the mantle dentin. It's the first increments of dentin formed next to the DEJ in the crown, or next to the DCJ in the root. Then where letter D is, the rest of that dentin is circumpulpal dentin. And again, you can see the tubules in the decalcified section. Then the last layer that's not mineralized yet, what's that again? That's the predentin.
Predentin.
Yeah, good. And then not shown, cut off, would be where the odontoblast cell bodies are in the pulp. Okay, so the rest of these pictures are, you know, shown in the presentation I asked you to watch that distinguishes paratubular from intertubular dentin, globular dentin, and interglobular dentin. And today we went over, you know, this this picture on here. So remember right here that here's the wear in the cervical area. There's no cementum. Here's the thin acellular cementum that's wearing away there from abrasion, and we can see here's the stimulus, the wear, and apical to that on the pulp side, that's where the secondary dentin formed. We'd have to look at higher magnification to see if it's regular or irregular. And then out next to the stimulus, the tubules were sealed off, plugged up with hydroxyapatite crystals, creating the sclerotic dentin. And then these accentuated tubules are the dead track. So here's normal tubules. Right in here where they're very dark, those are the dead tracks. All right, I know you gotta get to clinic, so I'll see you tomorrow at 12:30, and we're gonna be going over the salivary glands. All right.